Perego from HPC-Lab in Pisa. I will introduce very briefly our group when starts three short technical talks regarding different topics. First of all, me, Fabrizio, and Salvatore are really willing to thank Yandex for inviting us here and for organizing the great Sayari summer school, which was really successful, so very interesting. Thank you, really thank you a lot. This is the tentative outline of our contribution. I'll show you briefly two slides on our group and on the topic we are involved in, and then we propose to give three technical talks, which are somehow related, in the sense that the first, which I'll give, regards the problem of suggesting queries in the long tail, giving useful suggestions also for rare or queries or queries that were never seen in the past by the search engine. After Salvatore will give a talk about a higher level suggestion in which we are trying to give useful suggestions which are not strictly related to the task which the user is going to perform by exploiting the search engine, but instead are more related to a long-term mission which the search engine think the user is involved in at the moment. At the last, Fabrizio will give a talk about an efficient method for diversifying search results. First, this is a brief summary of our group. We are a group in Pisa, in Italy. We are 8 full-time researchers, and most of them are involved in web IR research, not only because as our name says, we started working on high-performance stuff several years ago, and a part of our group is still involved in cloud computing and similar stuff. Obviously, also we are interested in efficiency issues related to web search in particular. We are full-time researcher and also some research associates from other university in Italy. As an example, Salvatore, which will give the second talk, is a professor at the University of Venice. Now, currently, we have 11 PhD students from different PhD schools in both from Italy, except one which is from the University of District in Romania. Well, regarding web search stuff, the best way of summarizing what's our research topic we deal with is probably this tech clouds, which was done with the titles taken from our work paper published in the last 2 years. as you can see, we are mainly involved in search stuff, in efficiency uses, in query logs, analysis, and mining. The expertise is obviously related to this issue, whose mining scalable mining algorithms for contents, scalable techniques for usage web mining, and so on and so forth, by exploiting, in many cases, high-performance solution based on MapReduce and cloud computing and similar stuff. If you need more info, you can look at our website, where we can find the list of our paper, the contacts, and so on. Feel free of asking what you like when you want, also offline with emails. I'm going to start the first talk, which, as I said, regards the problem of suggesting queries in the long tail. This is a joint work made by people from our group with Yahoo Research in Spain, the Barcelona lab, but particularly with Francesco Bocchi. As you know, the main practice regarding query suggestion is exploiting the wisdom of crowds, which can the knowledge which we can mine from query logs and from the behavior of past user of the search engine, to provide different query which are related to the one currently submitted by each user. The main goal of this kind of techniques is from one side to shorten the length of the user session, thus try to driving the user towards her information need more rapidly as possible. And this has obviously an important effect on both in two different sides. From one side we have that we decrease the load incurred by the back end of the search engine, and so we can give more answers in the same time, and we can in some way increase the capacity of the system. And from the other side, we can also improve the quality of experience as perceived by the user. One of the main issues of current techniques for web suggestion are that are strictly targeted to head queries, queries which are very frequent. If you look Yahoo search engine, you can see that if we submit a query such as Moscow, the search engines provide two kinds of different suggestions. From one side, we have related queries, which in this case are really terrible, in the sense that we don't need the sentiment analysis tools we were presented in the summer school to see that are really quite bad suggestion provided in this also in this case. And another different kind of suggestion is for the query which are somehow related from a semantic point of view. In general, these queries are taken and extracted by the historical query logs storing the behavior of past user. These instead, most cases exploit external knowledge bases such as Wikipedia or similar knowledge bases. These are at the semantic level, in the sense that suggest things which are related for the entity induced by the queries, and these instead are given by the error system. When instead we submit queries which are not so frequent to the search engine, in most cases the search engine is not able to provide any query. As you see, if I submit to the Yahoo search engine, which is powered by Bing now, the query Rusayare DPT 2011, I don't have any suggestion, and even related entities are completely lacking. In this work, we tried to overcome to this issue, and in particular to provide a suggestion, useful suggestion, even for rare and never seen queries that are very important for search engines, in the sense that by considering the long tail distribution of topics of query, we have that rare or never seen query account for about the 50% of the whole traffic. The issue we want to address are rules. The one related to the sparsity of the recommendation models, which implies that the query assistance services such as query recommendation perform very poorly, or are even never triggered for long tail queries. And from the other side, we have also another problem, in the sense that if we provide suggestion for very frequent query, we can also think to compute them, outline and cache them in some way. And instead, if you want to provide suggestion for rare and never seen query, we have to compute the suggestion online with the query processing. So we have also the need of devising a very efficient method for query suggestion generation. If we start from the current solution to the query suggestion problem, we can consider as an example one of the most common approaches, which is the one by Boldi and others, based on the query flow graph, in which we have a graph built from historical query log, in which each node is a query present in the log, and each edge accounts for the probability of submitting a given query starting from the previous one. As you can see, for the query Barcelona hotels, we have a given probability of having a follow-up query, which is cheap Barcelona hotel, or Luxury Barcelona hotel, and so on, or also we have with some probability we abandon the session and go in this sync node. By using this model, the suggestions are computed by performing random walk with restart on this graph, starting from the query submitted by the user, which already implies that we cannot use this model for providing suggestions for a query which were never seen by the search engine, because we don't have an entry in the graph from which starting the random walk. We can say that this and many other approaches which are discussed in literature are query-centric suggestion. This has a very specific implication. In fact, in the case, as an example of query flow graph, using this suggestion model implies to perform random walk with restart on really huge graphs, which store a the long-term behavior or the multitude of different users for providing a good suggestion model. In the case of the query log we used, which has about 600 million different queries, which has from the Yahoo search engine OS. We have that after all the cleaning, the pruning you can do, which is based on removing less popular queries, so on. We have a huge graph with 30 million nodes and about 16 million of different edges. However, if you consider this query log, we have that if we consider the query present in the query log, which are a single occurrence, we have that this number account for about 30% of the total query traffic. Those already looking at this approach, we know that for the 30% of the query, this model is not able to provide any suggestion. If you see that for building the graph, we also perform a lot of pruning. You see that because from 60 million queries, we have only 30 million different nodes. We have that also rare queries are not covered by that model. On the other hand, our main idea is that if we turn from a query-centric approach to a term-centric approach, things can change slightly. In the sense that if you look at the same query log with about 60 million queries, we have that the term occurrences are 1,300,000,000. And if you look at the terms which occurring in the query log, but occur only once, we see that they are only 5 million, which is about 0.04% of the global term occurrences. Thus, if we are able to build a model which considers not the query, but the term appearing in the query, we can have more knowledge which regard the term occurring in the query, and try to provide suggestion even for their queries. this we try to build a different graph, which is called the so-called term query flow graph, in which we have consider the query flow graph as usual, which is built from the query occurring in the log and so on and so forth. And we put also a different level on nodes, which are the term occurring in the queries. Those we add all the term, all the direction on the term, and we put in an edge from a term node to all the query in the query flow graph, which contain that term. Those term node will have only outgoing link, which point on two queries which contain those terms. By adopting this graph, the suggestion for an incoming query are rules computed. A query composed by a set of terms T1 and Tm can be computed starting from the graph by extracting the centerpiece subgraph from starting from the nodes corresponding of the term occurring in the query. Thus, to extract the centerpiece, we simply perform M, where M is the number of different terms. Random walks will start from each one of the terms to the nodes corresponding to that term. And for each random walk, we compute the stationary distribution, and then we multiply component-wise the resulting M stationary distribution, and we got a set of queries which are ranked with respect to the query types.
Can I ask?
Yeah, sure.
Okay, so you have sort of two levels. You have transactions, you have edges that connect queries due to terms, and you also have edges that connect queries due to sessions.
No, query to query. There is in some ways query to session because an edge in the query flow graph account is present only if we have at least one session in the query log.
And so the weights on the edges are equal for the two levels?
The edge in the query flow graph this part of the graph are the same as in the work by Bolgi.
Okay,
in the previous, we instead divided the I do not know.
Well, actually, you can think of many different ways.
Yeah.
The one we adopted is the most naive one.
So we divided
counting the number of queries contained the term. So
one
over the probability of moving from the term.
Probably you can improve the model by measuring in some way the importance of that term for that queries. With TF, IDF, matrix, something like this. So we only divided by the number of.
So if you think that for some query it's better to look at the log. You can weight it by that. And
yeah,
for some
sure.
query, better the transaction. And if for some query, better look at the terms, you can weight.
Yeah, sure. For computing the effectiveness of the method, we adopted the usual way of performing a user study. We take a set of assessors between chosen among the students. They present them a list for each for a given set of query. In particular, we have the track topics provided for the diversification stuff in 2009. And then we choose the almost randomly in different classes of frequency 100 queries from Yahoo. We present to assessor a set of 10 results. 5 of them were computed by using query flow graph, which is considered as the baseline, and the 5 instead by using our method. And we asked to assessor to rate the suggestions provided in 3 different classes: useful, somehow useful, and not useful. And this is the result. You can see our main goal is not improving effectiveness, as we will see. In that case, it was possible because in the track topics for each query in the diversification task, we have a list of possible different subtopics. And so it is very easy to match the subtopics with the suggestion. In that case, it was much simpler. In this case, no, we didn't. We said which to assess the relatedness essentially, not really the usefulness, because it's very difficult to
So you didn't, for example, click on it?
No, we didn't start. We got at the end quite similar results in the case of the MS of the model trained with the Microsoft log. You can see that we have slightly different measures and so on and so far. The most interesting thing is instead the one which we are concentrated on. We have some anecdotal evidence in this case. We can give you also a paper in which we have more examples, also some different metrics. In this case, we have two queries which are not present in the query log used for training the model, or are very rare. As an example, the query lower heart rate, which is in the track, one of the track topics, is not present in the Microsoft. I do not remember in the Microsoft query logs. And however, our method is able to provide suggestions. These are the top 5 suggestions which are really effective for that query. This is the medical website. Sorry? No, obviously, in both the cases, the query flow graph was not able to provide any suggestion because that query was not present, and that query was occurring twice, and the threshold used for Pruning the graph was higher than 2, and so we got no suggestion by using the query flow graph model. Those we have some evidence that this model had some advantages over competitors. In particular, we can provide a suggestion of quality which are comparable or better to full flow graph, even for rare unique queries. The other issue we want to address is the efficiency one, in the sense that we know that computing random walk with restart is very expensive usually, and so by use on that graph, which has 30 million nodes, it takes about 5-6 seconds, if I remember, to compute a single random walk with restart. So it's not possible to compute online and suggestion of this kind of data structure. So we have to think to provide a different solution for achieve efficiency and to achieve our goal of providing online query suggestion. The thing is essentially possible because we moved from a query-centric approach to a term-based one. If you remember the number about where different query present in the graph and different terms, you know that we can think to adopt an index-based solution because we start not from the different queries which are about 30 million, and so in that case we had an index in which we can store the precomputing stationary distribution, but that index would result in 30 million different rows. But we start from terms. Terms are much less than different queries, and so we reduce the size of the index. And so we can think to pre-compute the random walks starting from each term present in the query graph, and storing the result is the stationary distribution in an index which resembles in some way an inverted index, in which we have a lexicon which store the term, and a list on posting where each posting is a different query ID and a probability. Obviously, when this kind of data structure, when you got when a query is submitted, we take all the terms from that query. We have access the index from the terms, and we perform the suggestion by multiplying the stationary distribution. This approach has the advantage that we have ODT where T is the set of terms in the query log posting list, but still we need a lot of space because each one of these posting lists is has a length which is proportional to the number of query in which the term appear to ODT. However, we can improve a lot. We can adopt some optimization. First of all, we can prune a posting list, in the sense we can order by decreasing probability the posting list, the query, and prune at a given threshold, a prefix threshold, this posting list, thus reducing the size of this posting list. We saw experimentally, which as an example by pruning, by considering only the 20,000 more probably queries for each term give a good result in which we have no loss in the quality of the result provided in the user study. We measured this dissimilarity of